Part A, we know this function that they gave us is b of a equals 1.73 times a minus 14.56 is modeled after f of x equals 1.73x minus 14.556. And we also know that this portion is really y wearing its fancy function clothes. Thus, we have a is like the x value, and that implies that a is our independent variable. Because normally we call x the independent variable, and b resembles our y coordinate, so that means that b is our dependent variable, because y is considered the dependent variable in a regular function. Part B, the domain. Well, the domain is all possible values of x, but x is being played by a, and we had a restriction over here on the a, so the domain are all ages from 15 to 44, and including, you see the equal portion means we're including 15, we're including 44, so the domain in interval form would be smallest value is 15 for a, the largest value is 44, we include 15, we include 44. So those are all the values for the domain, for the variable a, which is modeled after the variable x in this comparison. And so this is our domain in interval form. Part C, multiple birth rate for 22-year-old moms. Well, all we have to do to find that is to evaluate the number of multiple birth rate, when age is equal to 22. Well, according to our formula, let me put a cloud around that because that is important, b of a. That is equal to 1.73 times 22, because a is 22 for this question, minus 14.56. That is equal to, when you multiply 1.73 times 22, you get 38.06 minus 14.56. And then you line up the decimals and do the subtraction, you get 23.5. So those are, the answers there are 23.5 multiple births per 1,000 moms. Or I should say 1,000 women at age 22. Okay, let's go to part D. We're going to do the graph, and we're only going to consider the domain. Well, let's see what we already know. We know that b of 22 is equal to 23.5. So that implies that we have an ordered pair. We'll call it x sub 1, y sub 1, equals the independent variable is x, so that's the 22, comma, and the dependent variable y, that's the b of 22, which is 23.25. I'm sorry, 23.5. Alright, that also, so that's one thing that we know. We need a second point, because if we have two ordered pairs, we can do the graph. Let's find a second point, which I'm going to call x sub 2, y sub 2. Well, let's see, let the independent variable a be equal to 44. So let's find b of 44. b of 44 is equal to 1.73 times 44 minus 14.56, which is equal to, after we put it through a calculator, we get 61.56. So b of 44 is equal to 61 23.56, which tells us that our second ordered pair, x sub 2, y sub 2, is equal to 44, 61.56. So using this ordered pair and this ordered pair, let's do our graph. We're not interested in negative values here because the birth rate, we're only considering positive birth rates, and the age is restricted from 15 to 45. So let's start here at 15 for this axis, and let's move out to 45. Let's see, 15, 20, 25, 30, 35, 40, 45. Now this axis represents the A values, the ages of the mother. And over here, let's see, maybe we'll make this a little taller. Over here we're going to do increments of 10 for the birth rate. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so this is the age of the moms in years. And on this axis we have birth rate. Per 1,000 women. Okay, so let's graph our two ordered pairs. We have, let's see, we have the ordered pair 22 for the first coordinate. By the way, this is what we call B of A, so let's label this axis B of A. Okay, we have the ordered pair 22 and 23.5. So go out to 22 on the X or the A axis, that's about here, 22, and then meet the value on the vertical axis at 23. So that's approximately here. So these two will meet about this location. That's our first ordered pair, X sub 1, Y sub 1. Now let's do 44, which is approximately here on the horizontal axis, and its Y partner is 61.5, so you got 10, 20, 20, 10, 20, 30, 40, 50, 60, that's 60, and then 61 is just a little bit more than that, so 44 meeting 61.56. And another thing I want you to notice is that we can't go any less than 15. So when we draw this line, don't let it extend beyond 15 because we start, our domain actually begins. It begins at 15. So let's go ahead and connect these 2 points together with a straight line because this is a linear function. And stop when you get to the 15. We should have stopped here too. I shouldn't have this part on here. We should just stop at this point, so forget that. And stop at this point. So that's our picture, that's our graph. And the last part is part E. That's where we figure the mother's, let's see, the mom's age, whose multiple birth rate is 49.5. Okay, so what they want us to find here is, let me write it, part E. Find A when B of A is equal to 49.45. Okay, so what is B of A? Let's replace that with what B of A is equal to. According to the equation we have, that's 1.73 times A minus 14.56. That's the same as B of A. Bring down the equal sign, and then bring down this side, 49.45. We just need to solve this equation for A. Let's see. First, we're going to add 14.56 to both sides. These will cancel. We get 1.73 times A equals, this side is 64.01. And then we divide both sides by the coefficient of A, 1.73. And when we do that division, this cancels, and we get A equals 37, we round it